everyone. My name is Brianna Curl, and I will be your moderator for today's webinar on Designing for Assembly Guidelines for Effortless PCB Manufacturing. If you are unable to hear the presenter or see the presentation at any time throughout the webinar, please let us know in the chat and we will do our best to resolve any issues. If you have any questions throughout the webinar, please type them in the questions panel as they come up. We will have representatives ready to answer your questions directly during the webinar. With that being said, I want to thank you all for joining us for today's webinar and introduce you to our presenters, Jeff Keister and Sue Frederick. Jeff is an applications engineer with over 40 years of experience in the printed circuit board field. His focus is on OrCAD, Allegro, CIS, CIT, and CAD-Sync. Sue has worked with Cadence tools for over 25 years, both as a PCB designer and application engineer. Prior to joining AMA, she worked in a post-sales customer support at Cadence, focusing on the front-to-back OrCAD, Allegro, and PCB SI flows. Jeff will be presenting, followed by the demonstration given by Sue. Assuming we have time at the end, we will field some questions in a formal Q&A. Thank you for your attention, and now, over to you, Jeff.
Thanks, Brianna. Welcome, everybody, to this webinar. I hope that some of you can get some of it out of it. A lot of information here, and I'm going to kind of go through a PowerPoint with everybody. Today we're going to talk about what is the design for assembly, what is DFA. We'll also talk about why is DFA analysis needed, how does DFA analysis work, and why are PCB design DFA guidelines important, and then some of the DFA guidelines that are out there and available, and then how assembly houses can help you. DFA is a combination of two methodologies. You have DFM, which is designed for manufacturing, where you're designing your board so that your fabricators can build the boards easily and quickly and for fabrication. And then you have design for assembly, which is another group or another contract manufacturer that's going to be putting the parts onto the board. DFA enables a product design to be efficiently assembled with the minimum labor costs. What you want to be able to do is minimize the effort that you have from your assembly houses. And with DFA, a company can prevent or detect or quantify and eliminate waste, of manufacturing inefficiencies within the product design. So this is really helpful in being able to speed up your design and make sure that when you're running these through assembly and manufacturing, you can work together as a team, to develop product assembly methods, simultaneously while you're designing the boards. This shouldn't be left to be done at the end of the design. You should be practicing these guidelines while you're designing your boards. So what is design for assembly? So PCB manufacturing includes things like fabrication, of course, component sourcing, acquisition of components, assembly, and these are a few of the things that a good DFA incorporates to your design process so that you can support and enhance the PCB assemblers and the ability to meet your primary objective, and then that's quickly assembling your boards with ease and without less friction against what they have to do. In the PCB design and development, there are actually two stages that we know of. So you have the prototype stage, is where you're going to go ahead and you're going to run this through the assembly cycle. They're going to work out the bugs on that, and hopefully they've worked out everything by the time you hit the production assembly stage. So these are very important that you run these two stages so that we can minimize the cost while we're going through the complete production line. So why is DFA analysis really needed? So CAD systems today, basically the design rules are set for the designer. These are DRC rules, mostly working with component placement, as in, are parts too close to each other? Are the traces too close? Do we have enough distance between differential pairs and clock lines, spacing of power planes and things like that? This doesn't take into effect the DFA rules. CAD systems don't include all this technology, in that while you're designing those. So you want to look for some kind of DFA analysis while you're designing your boards. CAD systems don't control the alliance of the design to the assembly criteria at all. This is usually a separate tool or a separate option or a function that comes in with designers. A lot of engineers who are now designing those boards aren't aware of the capabilities that the tool has, and maybe they're just designing using DRC rules, and this is a big mistake. So doing DFA analysis while you're designing the board is very important. Technological processes of the assembly are often ignored by the designer at the design stage, and this is so true because a lot of them aren't aware of it. They don't really teach this in colleges or when you're getting your engineering degrees about how important it is when it comes to assembling the products. They're mostly concerned about just designing and getting their circuits working versus what's going to happen later down the line. So DFA analysis is going to bridge that gap between the design and production. And you're really going to want to be working with your contract manufacturers, and they play a big part in the designing of your board. So try not to leave them out of that. So how does DFA analysis work? DFA is the process of finding and fixing those critical issues to assembly of the printed circuit board out, usually in the prototype stages. DFA analysis of the printed can be conducted. The most CAD systems today, the more higher priced ones, not the Eagles and the dip traces and things like that, but the more higher priced tools are going to have some kind of DFA analysis built right into the tools. It's going to allow you to detailed automated verification of your design from the point of view of the production assembly house. So this is a good way to get an idea of what's going to happen when your board is becoming assembled. So you're going to want to be able to abide by these guidelines that are available. Conducting DFA analysis at the final stage of the product allows solving a number of problems arising, and you want to be able to do that when you're doing your design. You don't want to hitch your product development coming right into production at the NPI stage. So we definitely want to, there's a lot of contract manufacturers that have DFA analysis that they can run after you've designed your board, and you can work that way. But it's far better to be able to run these while you're doing your design. You're going to save a lot of time. You're going to be able to reduce the number of iterations while you're doing your design product. You're going to be able to reduce the time to release that to the market. You're going to decrease the percentage of defects that are available, after you've run these through your own software and then having your contract manufacturer run it through theirs. And you're going to increase the reliability of the device, the calendar life of the product, because by abiding by these rules, it's going to always be guaranteed that when we run these through the production cycle, these rules will already be built in for the assemblers. This is going to save a lot of money for the company that's releasing the product. So this is where you'll be saving your own company money. So why are PCB DFA guidelines important? There are several factors that contribute to the board being considered manufacturable. There's components that you've got, parts that are unique and are hard to find and purchase. You want to try to acquire those parts early in the design, and parts that are not readily available, which will be at higher cost. So you want to try to secure those parts before you send those off into manufacturing. Placement is very important as well. Placing your parts can affect the board is manufactured. So being able to place your components, in the right locations, maybe not putting them so tightly gathered around each other, worried about components that are small components that are, up against tall components so we don't have overshadowing. And even things like rotating can affect the solderability and the cost of your components. And then there's the layouts. Your PCB design will usually connect to other boards or other interfaces. So you're going to want to be able to talk to those other designs and make sure that you've got a full DFA assembly across your whole product line. This is going to help you to optimize assembly quite efficiently. So the effect of assembly problems, what are those effects that we're seeing out there? So we're seeing, you got reduced yields that are going to be a problem, reliability issues, or there's going to be a lot of field failures. It's going to cost you a lot more money to do respins. We want to try to avoid that. We're going to increase our manufacturing costs. If parts can't be manufactured and assembled properly, they're going to have to come back in and actually build those prototypes over again or hand solder those components on, which is going to cost you more. Project delay is going to be a ripple effect, and you're going to miss time to market. So there's a lot of issues that can happen with the assembly problems. It's not just about designing the board. So let's go over a couple of the DFA guidelines that are out there. and things that you should pay attention to. So pay attention to part-to-part spacing. It's very important that you don't get parts too close to each other because of the tongs that are going to, the assembly tongs that are going to attach to components. Can they be assembled easily without touching other components? Choose your components during the design phase. Make sure you're checking out to make sure you have the right component. If the factor is component sizes from the beginning might change to different sizes as you're going through your design cycle. You want to make sure that you've got the correct sizes that you're dealing with. Non-lead-free and lead-free components. You never really want to mix, lead-free components with non-lead-free components. You want to make sure that you're probably going with lead-free components and make sure you're using those. I know that your manufacturers and your assemblers will be greatly appreciated with that. And then evenly placed for large components. You want to spread your large components out. Make sure they're not so close to each other. This is very important. Make sure assembly contractors tailor to thermal profiles for the reflow, of unique assembly jobs. Avoiding mixed technologies. You don't want to be putting through holes and surface mounts all in the same design. And if you do have to put through holes, maybe you want to make sure they're all on the same side of the board rather than putting through holes on both sides of the board. So if you have to end up mixing technologies, be cautious of how you're doing that. Picking the appropriate package size. Make sure that the components that you're picking have the right footprint. You don't want to do a design change of you've got an 0402 layout and then somehow the engineer switches to an 0603 and you're unaware of that. So it's very important that you pick the appropriate package size. Look for long lead time components. If you guys are putting your own packages together, it's very important that you're able to get the components that you're going to need, and they might be long lead items. You don't want to all of a sudden turn that over to your contract manufacturer and then end up waiting for him to be able to get those long lead components. So be checking that out. Keep your BOMs up to date. Keeping a BOM up to date is very important, during the design process. The engineer might change a component due to long lead sizes or size problems or availability, and you might forget to update the BOM. So making sure that your BOMs are updated all the time is very important. And then carefully inspect your footprint development. During the design process, an engineer, sometimes, like I said, they might change the size. So you want to make sure that you have the correct footprint, for the component that's going to be mounted on that footprint. Be sure that the indicators are present. This is a very important, and it happens quite often. Designers forget about this. So it could be a showstopper if your pin 1 indicators aren't there, or your resistors or your capacitors that need indicators on there. So be very cautious to make sure that your indicators are present and close to the reference designator or the component that you're dealing with. Vias and pads should be filled unless they're a thermal pad. So making sure that all your vias, for your BGAs that are going to be installed in the board, making sure that those are completely filled is important. And try to have one pad, for every connection on the board would be great for every component. If you do have to share, be cautious of sharing maybe a resistor or capacitor, because you can come into component tombstoning, that can result in like the imbalance of the solder being pulled from one side to the other. And then ease of CAM setup. So it's important that when you're outputting your design, that you're not just creating Gerber. Contract manufacturers we are now beyond just Gerber data. So if you can output to ODB++ or IPC 2581, it's much better for your manufacturer to have that complete information than them have to take your Gerber data, sift through that, try to massage it so that it's in the proper format that they need, and put everything where all that information is already put into your ODB++. And then addressing component delivery. Are your components going to be able to be supplied on time? Can you get the components that you need, readily available to you? So it's important that you address that component delivery times. So these are just some of the guidelines that are really much important. So how can an assembly house, how can they help you? And you should use them. So working together with your contract manufacturer before and during the design gives you both the best opportunity of success. So your CMA should be, or your CM should be able to review your design to help you make the best component selection. So I've often, when I'm designing my boards, I often send them to whoever the contract manufacturer is, so that they can look at the placement before I start routing and get an idea of what's going on with my design, so that they can help me out. Maybe I have to move some components. Maybe I have components that are too close to the edge of the board. So it's important to work with your contract manufacturers while you're designing that board. The CM should also work with you on, like I said, in component place, but also for the manufacturing of that. So they'll be able to also run that through their manufacturing checks to find out if you've got the right component sizes on the correct footprint. So it's definitely a good idea to be able to work with your contract manufacturers, whether it's your fabrication house, or maybe they're also your assembly house. So work with both of those. And by helping you, with your designs, of course, you're going to have a good design. You're going to understand what assembly practices are for your future designs, and you're going to get better yields, better costs, and you're going to be able to get your design to market. For those of you that see this, you might want to write down this website. I'm not promoting this company at all, but I have found that they do have a nice PCB design guideline, assembly guideline. I really like this little PDF file that they offer for free. So you might want to jot down this web link, but it's nice to be able to go and download this and get an idea of some good guidelines and some rules when you're designing your boards. So good DFA assembly will definitely, you'll be able to see and fix the violations in time while you're designing your board. Sue's going to show you, how we can do that with the Allegro tools. You're going to streamline your design, to the release process, so that when the contract manufacturer gets here, he doesn't have to worry about all the different problems that you may have created for him. So by running them through your own DFA, you're going to be able to correct those problems. You're going to eliminate a lot of multiple validation iterations of going back and having to respin the board or create ECOs and things like that. So you're definitely going to do that. And then, of course, you're going to improve your time to market, which is really what our key goal of what we're trying to do. So there's a lot of advantages into using your DFA assembly that's built into the tool. So I'm going to turn this over to Brianna, and then we'll go ahead and demo the software for you.
Thank you, Jeff. I'm going to turn this over to Sue.
Okay. Thanks, Brianna. Thanks, Jeff. So I just want to give a little demo of some of the things that Jeff was talking about. Really, the whole point of doing this is to try to not have any kind of issues after your board is being sent out to the fabricator. So you want to try to address anything at the beginning. So the DFA process actually begins before placement in the board file. So when you're building up your schematic, you want to choose components that aren't near their end of life cycle and who have lead times within your delivery window, and you want to make sure that the components are available in distribution. So this is what's going to minimize the possible delays, production delays in the future. So the first thing I might want to do if I have my schematic is go and look in the company database to see what parts I can place in the board and see if there's any issues with any of them. So I can come in here and just search on a value if I want to try to find a 22 microfarad capacitor, for example. So coming in here, I actually have my database color-coded. So scrolling over, I can see that the company part status on this red line is obsolete. So it's been marked obsolete in the database. So this is a part that I don't want to use. I have another one here that's on order. So I might want to stay away from that one as well. So I could pick any of these other parts in here, or I might not even find any parts in the database, and I might have to go out and maybe do a distributor search. So here I can go out and search Arrow or DigiKey for parts that I couldn't find in the database. You can also search on parts that are in stock and RoHS compliant and lead free. And then this is going to show me the real-time information from the distributors, including the quantity on hand and the price. So it allows you to consider the cost and the availability before selecting a part. And I can sort on the quantity and the price and pick one that that maybe I can use in my design and then add it to the database. Now, if you want more access to part life cycle and risk analysis data, you can go out and search in the Silicon Expert database as well. So here I can search for manufacturer part number and run a quick search, and then selecting one of these, it's going to give me more information about the life cycle. So here you can say there's a high inventory risk. So you might want to start searching on other components to see what best fits your design. Then when you have your parts selected and placed on your component, you might want to, or on your schematic, you can bring up the part manager. Now this can be used to compare the parts in your schematic with the parts in the database. So for example, if you've had a schematic that you are redoing, or you want to check it, an older schematic, to make sure the parts are still available, you can come in here and run the part manager and update part status. At this point, looking at the company part status, you can look and see down here there are a couple of obsolete parts. So these are going to be parts that you're going to want to go in and replace in the schematic before you do another spin of it. And here's a preliminary one. So make sure that you check the part status to make sure that all these parts are available. You might also want to search on the value. So you could have some resistors here. So I have some 10K resistors, and there's two different part numbers. You might want to go back in and look and see if you can use all of the same part number. So that's fewer components that you have to go out and order. And these even have different footprint sizes. So just check the footprint sizes, make sure they're the right size, and make sure they're not too small. I mean, maybe where you're having your board assembled can't handle the smaller components. So just make sure they're the right size for the board assembly house. So now going into Allegro. So the DFA functionality in Allegro gives real-time package-to-package clearance checking during the interactive placement and while moving components. Since it's integrated into the Allegro's constraint management system, you don't have to export it out to an external tool. The checking is done in real time, and any DFA issues are resolved as you're designing your board, which is the whole focus of this. You want to be able to fix things before they go out to have your board assembled. So in here, I currently run a DRC check. I don't have any DRCs in this board. So looking at the DRC browser, you can see there's no DRCs. The first thing I want to show is the package-to-package spacing constraints. So in Constraint Manager, in the manufacturing domain, there's a design for assembly workbook. And this allows you to check, to set up constraints for package-to-package spacing, component to board outline spacing, paste mask, missing paste mask, things like that. So the package-to-package spacing, what this is going to do is look at your DFA outlines that are in your symbols. So your normal placement, your package-to-package placement, is based off of the place bounds that are defined in your symbols. So but they're not defining how far apart these components need to be in order to have your board assembled. So what the DFA spreadsheet is doing here is defining the distance, the minimum distance between components in your board. So right here, I have a spreadsheet that's already made, but if I wanted to add a different spreadsheet, I can by clicking on the tab up at the top. So what you can do is add just symbols, package symbols to the spreadsheet. Coming over here, I've just selected a few. Now, here I can define the distance between each of these packages. But as you can see, as you start adding more components in, this table kind of gets a little unruly. There's just a lot of information in it, and it's hard to find things that you want or set up your constraints. So what you might want to do is set up some symbol classes. And in here I have a few classes. I have a connector class and an SOIC class. So I know that my SOICs need the same spacing to other components. So I just put them in a class to make my table a little bit smaller. And in here I've also added a package. So my vertical SMA is actually just a package in my board. It's not classified anywhere because I need to define the distance between these SMA connectors. So I want them to be 200 mils apart from each other. And you can see that the spacing from my SOICs to my other SOICs is 50 mils, and to the connectors, it's 50 mils. So you can set up the spacing however you need to in order to get the minimum spacing for your manufacturer. Once you create a constraint set, you need to assign it to the design. So I can come in here and you can create different constraint sets for the top and the bottom. So you might have different spacing requirements on the top and the bottom of the board. But what I'm doing is I'm just assigning the same constraint set to both the top and the bottom. And just clicking in this top column, it's just showing me what my constraints are for that layer. So now if you notice up here that if the column header is yellow, it means that the DRC is not turned on. You can just right-click in here and turn on the analysis mode, and that's going to do the online DRC checking for you. So run a quick DRC check. Now, during placement, if I get into placement edit mode, I can place all of my SMAs down here. So I'll place the first one. And now as I'm placing the other ones, I have that 200 mil minimum spacing that I've set up in the DFA spreadsheet. So what that's doing is showing this DFA circle that defines that minimum spacing. So at 200 mils, I don't have a DRC, and I can place this down. So no DRC shows up. Now the next one I place is going to try to place it next to each, it's checking to each of the other SMA components. So as I start getting closer, you can see how it's going to create a DRC. So what it does, it kind of pauses at that minimum spacing that you have set, and you kind of have to force it through in order to get it to place with the DRC. So I'll place that down, it has a DRC, and then this one has some DRCs as well. So in addition to that working in placement mode, you can also move the components around. You can still have these DFA circles to help you guide your placement to make sure that all the components are far enough apart. By doing this in real time, you don't have to come back later and rework your design. So you might have an area of the board that's already routed. You've already sent your board out, and you come back in, and you're told, oh, these components are they're too close together. You need to move them. Well, now you have to go in, you have to move them, and then you have to move all your routing. So this is going to add cost, it's going to add time, and it's just better to have all this information at the beginning of your design to avoid these kinds of problems. So the next check is an outline check. So this is a component to board outline or component to cutout checks. You can also check your paste mask to the outline or paste mask to cutout as well. So same type of thing, create a constraint set. What I'm going to do is set one up for my component to outline and cutout. Let's say I want to be 100 mils from both the board outline and any cutouts I might have. Once again, my column is yellow, so it means my analysis mode is not on. I want to make sure I turn that on to get this online DRC and the real-time feedback. Once I have my constraint set, come into the design, assign it to the different layers. So I'm going to, again, assign the same constraint set to my top and bottom layers. You can assign different constraint sets to either side if you have different spacing constraints. Then just run a quick DRC check. And then look over here, you have a few DRCs. So there's some components that are a little too close to the board outline. You can easily come in, move these components out of the way. My DRCs are gone. And you don't have to worry about moving them after your board is already routed. Another check that you can do in Constraint Manager is check your components to mechanical holes. You can check components to pin pads, your paste mask to paste mask, and via pads as well. But I'm just going to set up component body to all holes. So create the constraint set, same as with the other constraints. Say I want my components to be 75 mils from my mechanical holes. Make sure that I turn on the analysis mode, and then come down and assign it to the top and bottom layers. So you can see now everything on top and bottom needs to be 75 mils from the holes in the board. And here I'm going to use the DRC browser to find my DRCs. I have 44 designed for assembly DRCs. Here's the component body to all holes. So I have 3 DRCs. I click on one of these. You can easily see that this component is too close. I can just quickly move it, go back to the browser, and then just easily move all of these components away from holes. You can see how easy it is to just fix these errors up front. Now, the last type of DFA check in here is a paste mask check. So I want to check to see if any of my surface mount pads are missing the paste mask in the design. So I'll create the constraint set. I want to turn on the check for missing paste mask, and then I also want to turn on the DRC mode. So now it's going to check to see if there's any missing paste mask. So coming into the design, I need to define what layers I want to use to check the paste mask. So since my paste mask is not defined in my stack up, I need to add a group. So this group, I can just name it and assign the CSET reference. So that's the CSET that I just created. And then I want to tell it, okay, look at the paste mask top and bottom for my pins, because that's what I care about, my component pins. Say okay, and now I have my paste mask is turned on, so it's going to go in and check for any kind of missing paste mask in the design. So coming back to my DRC browser, and here I have 8 missing paste mask DRCs. And these are all on one component. So it looks like the pad stack got built without the paste mask information in it. So I could come in and just modify the design paste mask in here. And what I'm going to do is I'm just going to copy the solder mask, and then just push the change back into the board file and run the DRC, and now those are all gone. So now you have the paste mask in your design. It was easy enough to find it in the design, and you didn't have to worry about it going out afterwards and coming back so that you could, so that you fix it after your design is complete. So one other thing that you might want to do is check your silk screen markings, as Jeff had said. Look for your pin 1 indicators. Make sure that your ref deses are close enough to the components that they belong to. You might even have 2 of the same polarized capacitors that are next to each other, but at different rotations. You might want to look into rotating them so that they're in the same direction to make it easier for your assembly house to assemble the board. So this is just a visual check. You can look at reports, component reports, to see what your rotations are and try to be consistent with your rotations. So you can see the benefit of running the DFA analysis as you're working on the design. It reduces the iterations of going out to your assembly house and having them come back and say, oh, you need to move this. You want to work with them at the beginning of the design to get the different constraints that are needed for your board. These constraints can be saved out and imported into another board. So if you use the same board manufacturer and you use the same constraints, you don't have to enter the constraint spreadsheet in every single time. So Cadence actually has been working closely with some board manufacturers on a DFM partner program. And through this program, you can work with manufacturers to define a set of manufacturing rules that are specific to your own design. So the manufacturer builds rules and sends you a file which can be read into Constraint Manager. And you can use those rules when you're designing your board to have the product correct by design. So correct to begin with before it goes out for manufacturing. So you can see that the DFA process starts at the beginning of the design by picking the right components, and it goes through to defining the spacing required in the board file. So inputting the constraints at the beginning of the design means that you'll spend less time going back and forth, and your design will be done right from the start. That's it. Thank you.
Thank you, Sue. And we will move into the Q&A, so please enter any questions you have into the chat now. If we are unable to address your questions immediately, we will be in contact with you. So our first question is, can DFA single logged errors be approved or somehow marked to be ignored?
Yeah, you can waive the DFA errors if you get them in the board, and you can accept them by just waiving them in the board file, and it turns the DRC marker 90 degrees so that you know that you've looked at it and addressed the issue.
Okay, great. So another question we have is, how do I get to the distributor search?
So that's through CIP in the schematic. So that allows you to interface with your database as well as go out to your distributors and to Silicon Expert if you want to do that. But you do need to use CIP inside of Capture.
Let's see.
I see one that's important. It's what's the difference between the place top bound top and the DFA bound top layers?
So the place bound is the traditional package-to-package spacing, where if you are placing components next to each other, what it's going to do is it's only going to DRC when those place boundaries overlap. The DFA boundary is what's being used in that DFA spreadsheet to determine the distances between the components. So your DFA boundary might be slightly larger than your package boundary to encompass the entire part.
Okay. And then I see another question from Ron. He's, where can I download these DFA, DFM constraints from manufacturers? Like Sue did show you that you can go to the Cadence website. I think you can call that up, Sue. That Cadence website. So there's a whole list of manufacturers that are available to you that you can talk to, and they will send you. You could give them what you're looking for, and they can help you out. Lots of good questions.
Yeah, great question. So we have someone who's wondering, Sue, if you could show again how to get the package-to-package spacing bubbles to show up.
Sure. So what you need to do is just in Constraint Manager, you have your you have to set up the spreadsheet in here, and then when you are placing the components in the board, and this is with Allegro. So the OrCAD professional product abides by the DFA rules, but you will not get the bubbles with the OrCAD products. You need to have Allegro PCB Designer or above in order to get them. So that could be why you might not be getting them in your tools. But if you have your spacing spreadsheet set up, it should be showing the bubbles automatically in Allegro.
Great, thank you. So our next question is, why is ODB++ better than Gerber to give to my CM?
So Gerber data is really an outdated data. Most manufacturers now have, tools like Valor, for example, and by giving them just Gerber data, which is just dumb data, X and Y locations, on, off, that's all it is, they have to manipulate that data. Whereas if you give them the full ODB++ data, all that information is integrated into that file. The layer stack up is there. All the solder mask, all the paste layers are all there. They don't have to adjust any of that. So really, you want to start getting away from ever using Gerber data with your manufacturers. You can also ask for discounts because they do have to manipulate that, so your NRE could drop as well by giving them ODB++ or the IPC standard format. I like ODB++ because, like I said, probably 98% of the fabricators and the assembly houses are using the Valor tool, and they're going to want ODB++ so they can read that in directly. So try to eliminate using Gerber anymore. It's fine if you want to create Gerber to create PDF files, or maybe have somebody internal look at that. But really, in the day and age now, ODB++ is really the standard that you want to be able to send to manufacturers. How do you create templates so other people can see those templates? Where was that? From somebody. How do you define a template of part spacing rules that is available for all users in the company? You know that, Sue?
Yeah, so you can just export a technology file from Constraint Manager, and in here you can define what you want to save out in the file. So I could come down at the bottom, say, export my design for assembly checks, and that'll save it out into a technology file. You could store this at a location that anyone in your company can access, and then set a path to it, the tech path, I believe it is, to point to the tech files that are available to use. And then when you want to read it into another board, you can just import it. So a file import technology file, and that will import the file, the technology file that has the constraints in it.
Great, thank you for showing us that. I have a comment here by attendee who offered some advice saying the self-net DRC is a very good DFM practice since PCB fabricators see copper to copper, not net. And I just wanted to mention that for anyone else who may find that useful. And let's see some other questions. Is there a video or tutorial that I could watch on how to learn how to use the functions?
I believe on Cadence Online Support there might be some information on how to set this up. If we want, we can always send information out too. If Brianna sends me your email or something, I can always point you in the right direction.
Absolutely.
I got one from Miguel. He's wanting to know if there's any training on footprint creation. Yeah, there is some training on that. I think you can get that either on our Allegro training, but now having to build your own components is almost getting obsolete with all the distributors now building all the components to IPC standards. So, I mean, it should be very rare that you need to build a component. And then we also have a tool called Ultra Librarian, that if you can use that tool of ours to find and locate components, and we have the schematic symbol, we have the footprint, and we also have the step models for those components. So really building your own components anymore is slowly becoming a non-necessity anymore. So definitely check out those other tools that we have.
So our next question is it possible to manage sets of DFM, DFA rules to be reused in multiple layouts, for example, for the same type of product or same manufacturing line? If so, can this set of rules be version managed?
So the rules, I mean, can be saved out to a technology file and used in another board. In terms of versioning, I would think you would need something like the ORCAD EDM tool in order to control the versioning of the tech file.
Thank you. Miguel also wanted to follow up with his other question on, is there training for writing scripts for the output of Gerbers?
I mean, there's the scripting language in Allegro, but I don't know if we're talking about skill programming or just the Allegro scripting language. But there is no specific training for that we offer.
Thank you. I believe we got to all of our questions here. So do you have any other information that we weren't really able to touch upon during our Q&A? We will follow up with you individually after the webinar, along with those who may be interested in seeing the CIP-CIS webinar that we had previously done as well. And so at this point, I would like to thank you all for joining our webinar, and thank you, Sue and Jeff.
Thank you, Brianna.
Thank you.
Bye.